So today I'm going to talk to you about how molecules are polar and nonpolar. We started with the question of how many of these molecules are polar. We start out with SO3, OF2, BeCl2, CCl4, and O3. And I'm going to go through one of them as an example, and then I'm going to use the others as extra examples to see how they all work out. So the one that I chose was CCl4, which has 32 valence electrons, 28 from Cl, and 4 from carbon. So in the Lewis structure, each of the Cl's is going to have 6 electrons with 1 bond to the main atom carbon. Since the chlorine atom has a higher electronegativity, the partially negative will be on the chlorine and the partially positive charge will be on the carbon, which makes all the dipoles point out towards the chlorine with the positive end on the carbon. The domain geometry of this molecule in particular is tetrahedral, and since there are no lone pairs, the molecular geometry as well is going to be tetrahedral. This molecule is nonpolar and there's no net dipole because when you look at the molecular geometry, all of them are pointed out, which will cancel each other out. So the next one is SO3, which has 24 valence electrons, 18 from oxygen, and 6 from sulfur. So as you can see, I already did the Lewis structure, and there's going to be double bonds to all the oxygens, and 4 electrons on each of them. The oxygen atom has a higher electronegativity, so it will have the partially negative, and sulfur has being the partially positive. So all the dipoles will be pointed out towards the oxygen atom. The domain geometry of this one is trigonal planar, and as well, this one will also be, the molecular geometry will also be trigonal planar. There's the net dipole will cancel and leaving this atom or molecule to be nonpolar. In the OF2 atom, there's 20 valence electrons, 14 fluorine, and 6 oxygen. And the Lewis structure will look like this: 6 on each of the fluorines, 2 on the oxygens, and the net dipoles will be pointing outwards because the oxygen has a partially positive. The domain geometry is tetrahedral, and the molecular geometry is bent because of these 4 lone pairs. And this molecule is polar because of those lone pairs, and the dipoles will cancel out because they are pointing in opposite directions. Next we have BeCl2. There's 16 valence electrons, 2 from beryllium and 14 from chlorine. In the Lewis structure, there's going to be 6 on each chlorine atom and only 2 bonds on the beryllium because it is an octet violator. The partially positive is beryllium and the chlorine is the negative, so the dipoles, like the other ones, will be pointing outwards. The domain geometry and the molecular geometry is linear, and there's no net dipole because they cancel out, which leaves the molecule to be nonpolar. Last but not least, we go to the O3 molecule, which has 18 valence electrons, 18 from the oxygen atoms. And this atom has resonance, so either one of these is correct because they both have 18 electrons on them. Either you have a double bond to this atom or a double bond to this atom. Either way, it's correct. The domain geometry is trigonal planar, but the molecular geometry is bent because of the lone pair here and here, which leaves this molecule to be polar. Some of the common mistakes are usually drawing the Lewis structure wrong, which will make your whole problem wrong, and using the molecular geometry instead of the domain geometry to find out if the net dipole in order to get the nonpolar or the polar.